Good afternoon, everyone. Thanks for coming. I have been working on this project almost 7 to 8 years now, and considering the development of the app to uh, human trial, and but the result of this study is pretty simple, small, maybe one or two graphs I can show you. So most of the time we will spend on chatting how this project was developed, how we got the idea of developing this app. So the story started back in 2012. At the time, I was doing residency training in New York, Montefiore Medical Center of Albert Einstein College of Medicine, and my family was living in New Jersey. So when I come home, my son at the time, he was 7 year old, and he used to play with my phone, play some game on my phone. And so I allowed him because he does not have any device at the time. So one day I was noticed that he was playing game and shaking the iPhone a couple times. I asked him, honey, what are you doing? He said, I'm playing game. I said, I know you're playing game, but why are you shaking the iPhone? He said, well, Baba, this is, if you shake once, then iPhone senses yes for this particular game. And if I shake twice, then it senses no. I kind of think how iPhone senses shaking, number of the time he shakes. So you probably already know this. The iPhone has a accelerometry chip, which I didn't know at the time. This accelerometry chip helped iPhone to measure the speed of movement of an object, and also the chip senses the iPhone movement, and that's why iPhone is able to measure your steps, number of the steps you take a day, and this chip also senses the angle at which iPhone is being held. So after that, I completely forgotten about the conversation about the subject. At the time I was doing my residency training, it is pretty tough. And I moved to Jacobi Medical Center for a rotation. And in my rotation, one of the attending physician, his name is Pranivicius. He's very well known for out-of-the-box ideas. So one day he told me, hey Ratan, we are doing a case together, and the patient is very frail, and she has histio-myasthenia gravis, and surgeon wants us to completely paralyze. They said patient should not move, and I'm going to do the train of 4 measurement, quantitative train of 4 measurement for the entire case. And I never heard how to do quantitative train of 4. So he brought this device, he showed me how to use it, and I thought it's pretty cool. As you see here is a first to each, last to each. It shows numerical value, a percent of the blockade. So when I was doing this measurement with the device, I recalled the conversation I had with my son, and I thought that if this device can measure the train of 4, iPhone should be able to do the same thing, because it's same accelerometry chip. So at first I did some Google search to see if anyone had this crazy thought like me, use of iPhone for train of 4 measurement. I found one letter to the editor, which is published in Anesthesia. And in this device, Dr. Langford from United Kingdom showed that iPhone can be used for monitoring neuromuscular function. So what he did, he used a eye seismometer app. The app is basically used for detecting the earthquake, and it doesn't give you train of a ratio or anything. It just give you a waveform, the first to each, last to each. He basically said that it is possible. It's not perfect, but it's possible to measure the train of 4 ratio this way. So I thought that nobody has time to use ruler to measure the size of the waveform from this eye seismometer app, and why don't we ask the developer to make an app specifically for anesthesiologist, which will automatically measure the height of the twitch and give us a ratio. So I contacted the lead developer of this app, Kiichi, who is also involved in this project. So he initially he's not convinced that this app should be built. So I had several back and forth conversation with him, and then he agreed to talk to me. I showed up in his New York office, and I tried to convince him for almost 1 or 2 hours that the world is waiting for this app. This is a earth-shattering, this is a groundbreaking app. So he then he developed the app, and the first few versions of the app didn't really work, and the third version or fourth version, I don't remember, looks like it was stable, and it can measure the train of 4 measurement. And then we submitted the app to Apple App Store. The app got rejected because Apple thought that it doesn't have much public interest. It is a useless app. Then we submitted a video description of the app, describing how why app can change the world. Anyway, so after that, app was approved. After the app was developed, I presented this app development, this app in ASA meeting. At the time, I didn't have any comparative device to check if the device is producing comparative output to other device. And after that, again, I forgotten about this app. I'm a pain guy. I have other focus. I totally forgotten about this app. And then I moved to Minnesota. I one day met with Mike Todd. I showed him the app. At first, he was not very convinced that it is a good app, but he has this black box thing. He has this steam pod, and he and I did measurement in a couple of the patient, and we both of us convinced that it is not 100% perfect, but it has some flaws, but it produces an identical output as the steam pod. So we decided to do a prospective observational study, and we submitted IRV. IRV actually was a nightmare. IRV came up with a comment like that this iPhone emits the radio frequency energy, and this radio frequency energy do not meet the FDA requirement for exemption of the device. And really, it is how many hours we use iPhone, like 5, 6, 7 hours. My son uses for 16 hours. And on average, in a year, we use thousands of hours iPhone very close to our hand. And for this testing, we just need only 10 to 15 minutes. iPhone needs to be closer to the patient's hand. So as Mike Todd said, we are not quite sure how to respond. So So anyway, after back and forth conversation, and it took almost like 8 to 10 months to get this study approved. After approval of this study, we are having difficulty to secure the iPhone to the patient's hand. But whatever I do, like duct tape, silk tape, plastic tape, it just give very inconsistent result. So when I stopped the patient enrollment almost like several months, I got so frustrated that I told Mike, I think this project is a failure. We couldn't get consistent data because we couldn't secure the iPhone to the patient's hand. Then Mike said, well, why don't you go to a hardware store, buy some of this cheap Velcro, and that should work. And actually this suggestion was a game changer. And after that, we don't have any problem in securing the iPhone to the patient's hand. So here I will show you how you can secure the iPhone to the patient's hand.
iPhone to the patient's hand. I will show you how to use this Velcro that you can get at Walmart, Home Depot to secure the iPhone to the patient's hand. I need a hand. See? So you want to make sure that the soft part is out. You want to hold it so that it can tighten. And then you have to twist the end to secure it. Now the iPhone has a sticky side to it, or a scratchy side. Stick it on, and now it's secure.
Okay, so you secured the iPhone to the patient's hand. Now what? How iPhone measure Train-of-4 ratio? Let me show you with another video.
This is how the Train-of-4 iPhone app works. With neuromuscular stimulation, this is how the Train-of-4 iPhone app works. With neuromuscular stimulation, muscle contractions are detected by the accelerometer chip of the iPhone and displayed on the screen.
All right. So we enrolled 28 patients for this in this project, and here you see the demographics of these patients. Most of the patients are ASA 3, which you can expect from the East Bank patient population, and most of the patients we tested in the GI room because of the rapid turnover and a lot of cases. And here is the one example of how iPhone app, this Train-of-4 app, measures after the Train-of-4 ratio after anesthesia induction. So here, for example, if you rocuronium was given, and maybe 20 to 30 seconds later, this is the first trace, you see a Train-of-4 ratio of 0.9. And these are not successive, maybe 20 or 40 seconds later, you see that is 0.7, and then another 20 to 40 seconds later it is 0.4. But you do not actually need to measure Train-of-4 ratio for induction. And you have plenty of ways to know that whether the patient is completely paralyzed. But the app is some utility to make sure that patient is completely reversed from the neuromuscular blockade. So this is an example again, and after the reversal given, here you see that StimPod and iPhone app is assessing the Train-of-4 ratio. Although initially you have some differences, but in the end, iPhone accurately detected the reversal as StimPod.